Okay, now it's your turn to try one of these things. In this video, we're going to be looking at finding a volume of a solid with a base in the XY plane. We'll give you some boundary curves. And then the cross sections of this will be parallel to the y-axis perpendicular to the XY plane. In other words, slices with the constant x will be squares. So very similar to the last example, but this time I want you to work it out yourself and then come back and get a solution. The integral to find is a little bit easier than the example we did in the last one. So find an exact and approximate values. So find and illustrate the volume of the solid with a base in the xy plane bounded by y equals sine of x plus 3. I'm sorry, that's the same formula. Let me change this to what I want it to be. Okay, here we go. Y equals 4 minus x squared, y equals x minus 2, x equals negative 2, and x equals 2 are going to be the boundary curves for the region in the xy plane. That's the base. And then sections, cross sections where x is a constant will be squares. Okay, so if you would try to find it, illustrate the base graph, illustrate also the 3D graph using the app that I showed you last video, which is, here's the link to it right here. You can use that for cross sections that are square. And then also figure out the exact, set up the integral, then evaluate it exactly in well, it's going to turn out to be a fraction decimal form. Do it exactly in both forms. All right, do it yourself. Come back when you think you got an answer and check it against the work that comes following this. Press pause now. Okay, well, if you're back, now you should have gone to some sort of graphing program, such as, well, you could do this in a graphing calculator, or I did it in GeoGebra. Here is 4 minus x squared. Here's x minus 2 for the bottom. This is an example of a strip there that we're cutting it with, which has a height of 4 minus x squared minus parentheses x minus 2, close parentheses, or that reduces to negative x squared minus x plus 6 is the height of this. And of course that height will vary depending on where this point is on this line, or in other words where that x value is going across. In 3D it looks like this. You can see the curve on the top here is this curve down here in the XY plane, and the curve here, which is a straight line, is the bottom, which is the base right here of that. Notice they do intersect at a point here, so these squares will get smaller and smaller all the way down to just a point here. And as we go back, they sort of have a maximum height in the middle, and then but they're squares all the way through this thing. Here it is in the app. You put in your formulas here and here, your boundaries here and here, and this one allows you to move, and you see that we get squares no matter where we slice it. If we were to turn this, let's see, looking straight at the x-axis, we'll see the squares. Actually, yes, squares. Of course, they come down all the way to nothing there. If you look at the bottom, there's the, we turn it the right way, there's the curve we were looking at. Let's see. And there's the 3D version of it there. Okay, so that gives you this. This little slider here will make it solid, where you can't really see the inside, all the way to you know, completely transparent. You can only see the slice. Okay, so let's go back to there's our illustrations again. And so our volume then is going to be a thickness of dx, a length of the base here of this base of our square is minus x squared minus x plus 6 right here, And we're going to square that because that'll give us an area of a square multiplied by a thickness dx. That's a volume. And we'll really delta x, take a limit as delta x goes to 0 and the number of little slices goes to infinity. And we get an integral with x running from -2 to 2. And squaring this out, okay, let me look at that just a minute. Okay, so we need to take this -x² minus x plus 6 and square it out and expand that out. It turns out to be a 4th degree polynomial. You can see the multiplication over here. 6 times 6 is 36. 6 times -x is -6x. 6 times -x² is -6x². -x times 6 is -6x. -x times -x is x². And -x times -x² is positive x³. -x² times 6 is -6x². -x² times -x is positive x³. -x² times -x² is positive x⁴. Notice I've lined up like terms, and when you add it up, you get x⁴ plus 2x³ minus 11x² minus 12x plus 36, which is what I have here. Then it's pretty easy now, since it's a polynomial, to take an antiderivative. Just the powers all go up 1, divided by the new power. X to the 5th divided by 5, that's 1/5 x to the 5th. That's x to the 4th. 2 divided by 4 is a half. It goes x up to the 3rd, and this is -11/3. Then for the coefficient, x here goes at x². 12 divided by 2 is 6. It's negative because those are negative. And then the constant term picks up an x. Evaluate from -2 to 2. So you just take that expression, everywhere there's an x, put in a 2, minus same expression, everywhere there's an x, put in a -2. Just some arithmetic left. 2 to the 5th is 32 times 1/5 is 32/5. One of those 2's cancels that, leaves 2 to the 3rd, which is 8. 2 to the 3rd is 8 times -11 is -88, and then divide by 3, that's -88/3. 2 squared is 4 times -6 is -24. 2 times 36 is 72. I'm going to have a minus here. So here I have 5 negatives and another negative. That's 6 negatives makes positive when we're multiplying. So this becomes positive. 2 to the 5th is 32 times 1 is 32, and then it's over 5. So it's positive 32/5. Here we have 4 negatives, and this one makes a 5th negative, so that's going to be negative overall. Again, a 2 cancels, and you get 2 to the 3rd is 8. Here you have 3, 4, 5 negatives, makes a negative. 2 to the 3rd is 8 times 11 is 88, and that's over 3. 2 squared is 4 times 6 is 24, and we have 1, 2, 3, 4 negatives makes a positive. 2 times 36 is 72, and we got 1 negative, make that 2 negatives, so that's a positive there. And then just add this up. If you'll notice, every other term is going to cancel out. So that 8 cancels that -8. The -24 cancels that 24. And so, but the others double up. We've got a 32/5, another 32/5, that's 64/5, and then we've got 2 of these, so it's a -176 and 72 and 72 is 144, and you have to get a common denominator at that point and add them up. I'll leave the details of that for you, or you could do it on a calculator, and you get 1,472 over 15. And if you do the long division here, which you might do in a calculator, you'll get 98.13 with the 3 repeating. So those are both exact answers in a repeating decimal form, and probably better, a fraction form. You can check this with your calculator. Here I checked it with a TI Nspire, and we found the exact value, and then I told it to approximate that. Of course, you could at least check the approximate values with a TI-84 calculator. It may or may not convert that to the correct fraction form for the answer. So there's a good one for you to try. Let's try another one in the next video where we have some different shape. Instead of squares, maybe let's try some triangles or rectangles or something. See you then.